All right, here we go. So this is normally my opening slide. I have my own name down at the bottom, but I put in a little subtitle to convey just a sense of what a daunting task this is, to try to give a kind of overview of or really just a taste of some of Yuda's contributions to causality in 25 minutes or less. I also normally have a big picture of my own smiling face on my no, I don't. But this isn't about me today. So here's Yuda. So I'm going to pick it up where we left off, which is with the work in probabilistic reasoning, and just one aspect of that is the use of, can you read that at the back? I'm not sure what I can do if you can't, but graphs are used to encode probabilistic information, and the idea is if we've got a framework here with a graph with some variables at the nodes, and yeah, maybe that'll help a little bit because you don't need to see me. And we've got a probability distribution over the variables, and we have a directed acyclic graph, and this can be used to encode various probability relations. And in particular, if the probability distribution in the graph are related by a condition called the Markov condition, then what Yuda shows in his 1988 book is that there is a purely graphical criterion for when we have probabilistic independence relations. So when one set of variables is probabilistically independent of another given some third set, and just by looking at the graph you can tell when those relations hold. So this is a really elegant work. And that's just d-separations, the name of the criterion. But so I guess I could have called this the revolution of 2000, but really the revolution started well before 2000 in the late 80s. That you just started to think of these graphs instead of just thinking them as encoding information about probabilities, started to think of them in causal terms as representing causal relations. And one of the motives for this change was psychological, and this is something I think that's been a recurring theme, the emphasis on trying to think about how we reason and how we think. That most people find it very unnatural to reason directly in terms of probabilistic independence relations. We sort of don't see what's probabilistically independent of what. And one simple illustration of this that Yuda uses is known as Bergson's paradox. There's those of you that are familiar with the Monty Hall paradox. It rests on exactly this point. So if you've got a structure like this where x and z are both causing y, that what happens is that x and z are unconditionally independent, but are dependent conditional on y. And this is kind of very counterintuitive and sort of unrealistic to think people are walking around with these conditional dependence relations in their head, whereas people tend to be sort of good qualitative informal causal reasoners. So it seems much more psychologically realistic that people are walking around with kind of informal causal models. So I mean, that's just one of the motives driving this change. Was it 1990 or 1991, together with Thomas Verma, he proved a really quite remarkable theorem. So if we think of each of these variables, the value of the variable is a deterministic function of its direct causes together with error variables. So I've got these added error variables, right? So I've got a sort of deterministic model. But now we imagine a probability distribution just over the error variables. And that's going to induce a probability over what are now the endogenous variables. And what Yuda showed is that if the error variables are independent, then the probability that's induced on the endogenous variable satisfies this Markov condition. Now why is that important? It means all of a sudden we can take all of the results the 1988 book, and we can start doing that with causal models, right? So we can have causal models that represent the causal relationships between different variables. And now just using graphical means, just by using those graphical devices, we can determine what probabilistic independence relationships are entailed by a causal model. So this is really sort of amazing to now just being able to look at the causal model, and just by looking at the qualitative structure of the causal model can infer by graphical means what the implied probability relations are. And then, of course, inversely, if we're given a set of probability relations, we can infer what causal structures are compatible with that. So you think that might be enough to call it a career, but wait, there's more. Another important contribution is this distinction between seeing and doing, right? So if we have some variables and we, let's say, observe the value of a variable, right? So here's Inspector Clouseau looking very closely at variable f. This is kind of a simplified version of a model that actually is used in chapter 3 of the 2000 book, but it's a sort of pared down model. So here's Inspector Clouseau looking at the value of variable f, and we know what we can do with that information, how we can reason probabilistically with that new information. We update the probability distribution by conditionalization, the sort of normal Bayesian means. But Yuda was interested in a different question. What happens if we intervene to set the value of a variable? So we're no longer just passively watching it. We say, I'm gonna tell this variable f what to do. So here's Ralph Nadal or somebody who's gonna set the value of f. And you can't just use the same apparatus, because what happens is that this is changing the causal structure, right? Now this variable is no longer having its value determined by what previously were its direct causes, but it's got this new source, right? And this is often the question we're really interested in when we're thinking about policy changes, when we want to know, whether we should be taking a certain type of medicine to treat a disease and so on. So this is an incredibly important question. And Yuda set the problem and sort of gave it the most general possible formulation. So we could even have some variables that are unmeasured. So we know it's out there, but we have no idea what it is. We don't have information about any of the parameters, how it's correlated with the other variables. And the most general form of the question is, what probability distribution do we get on y if, and here we can think of y as generally some set of variables, if we intervene on one set of variables and observe the value of others. So this is kind of the most general form of the problem. And so this is really a causal quantity. We want to know what's going to happen when we intervene on the value of a variable. So we're not just interested in kind of observed correlations. And the question is, can we express this causal quantity using just the probabilities that we've observed, just the probabilistic correlations? And in answer to this question, he developed what he called the do calculus. And this is really a quite simple calculus. So first of all, he presented a very precise characterization of when this can be solved. So we know exactly when this problem can be solved and when it can't be solved, depending upon where the unmeasured variables are. And he created a calculus of just 3 axioms, a very simple calculus. And this allows us to compute the value. And so the calculus allows us to substitute terms without the do operator for terms with the do operator. It allows us to calculate this causal quantity whenever it's possible to calculate it, and just very recently was shown to be complete. So we've got a sound and complete, an entire sound and complete logic of of causation, of intervening and learning about the effects of interventions. And now I want to put my philosophical hat on and to say that I mean, part of what impresses me about this is not merely that he solved the problem, but also that he asked the question and that he provided a framework in which this question could be very precisely stated in its more general form. So as philosophers, we're typically much more impressed by clever questions than by clever answers. The kind of joke is answers put us out of business and questions are what keep us in business. So being able to provide the framework in which this question can be asked in its most general form is, of course, the first step towards solving the problem. So kind of what you had before is a lot of vague talk about capturing causation in terms of probabilities, but without really a kind of clear statement of what the problem is toward which people are trying to find solutions. So I think part of what's interesting about this is just providing the framework and then stating in the clearest and most general way what the question is, what the problem is. Oh, and then solving it too. That's important as well. But even just setting up the problem really very insightful and interesting. But we're still not done. So I'm just going to talk about one other thing that he's worked on. There's so many things I'm obviously leaving out. And this is the concept of actual causation. So this is the last chapter of the 2000 book. And this involves what retrospective causal attribution. So after the fact, we say things, and this is expressed in natural language in the past tense. We say C caused E. So for example, of course, you read through his books, you get all sorts of lovely examples. So Susan's distracting the chef caused the soup to boil over, right? So it's a causal attribution. It's expressed in the past tense. We've observed these events, and we say that one of these events caused the other event. And this is a kind of concept, a kind of attribution that's often important in the assignment of moral and legal responsibility. So a court of law has to determine whether the defendant caused some harm to the plaintiff, and so on. And in making moral judgments, we want to know whether somebody caused some particular harm. So it's this kind of causal attribution that's involved in assessments of responsibility. And this is something there's been a huge literature on in philosophy, and there's a long tradition of trying to understand this concept of actual causation in philosophy. So Judea was really jumping into a quagmire here in writing about this. And just to comment on one thing that I thought was really profound and from which I think I really gained a deep insight from reading this is that in the philosophical literature, what Judea was calling actual causation was usually just called causation. So people would write about, I am giving an account of causation. And you can understand that it's just coming from the surface grammar of the claims that are made. C caused E, Susan's distracting the chef, caused the soup to boil over. We don't say was an actual cause of in natural language. So the surface grammar suggests, oh yes, this is causation that we're talking about. But I think this created a really serious misunderstanding in philosophy, namely the thought that somehow actual causation was all there was to causation, that to understand causation was to understand this really very specialized concept of actual causation. And I think that confusion, it's one that's still around, and I think one that's really impeded progress. And what Judea did by placing it in the broader framework, I mean, to my mind, merely the fact that he could write 9 chapters on causation before talking about actual causation was itself significant and telling, right? That this sort of really drove home to me this idea that that this concept that philosophers have been worried about was really this kind of specialized concept within a much broader framework. So just to say a little bit about this, because the basic idea is fairly simple. If we say that the value of one variable is an actual cause of the value of another variable, what this means is that when we intervene on the value of the first variable, so when we intervene on f, so there we are intervening on f, so it's not necessarily whether y changes when we intervene on f, but when we intervene on f, while possibly also intervening on other variables to set them to some set of permissible values. And a lot of the hard work goes into spelling out this idea of what counts as a permissible value. That I won't try to do in my 25 minutes or less. But sort of the idea is fairly straightforward and kind of comes out very naturally in this framework. I want to and then the idea is whether when you do this, the value of y changes. So there it's changing color. That's to let you know the value of y is changing as you do these interventions. I wanted to say just a little bit about what I think are some future, interesting future directions on this, since Joe Halpern couldn't be here, and this is something that Joe and I were working on, and I wasn't sure whether I'd be allowed to say this, but this is something we talked about in the paper that we jointly wrote for the Festschrift. I carefully left any reference to the Festschrift off my slides. I didn't want any of the secret to get out. So one just I think interesting future direction here is that a number of considerations suggest that it would be helpful to build in information about norms and defaults into causal models. So to say, for instance, that a variable has a certain default value, that in the absence of other information, we assume it has a certain value, or a variable has a normal value. And there's a lot of evidence from psychology, and many of you may be surprised to know that this is a field, experimental philosophy, but this is actually a field that show that people's judgments of actual causation are affected by norms and by defaults. So things, you can have sort of exactly the same example, but if you set it up so that what somebody does is abnormal, people are much more likely to judge it a cause than if it's normal. So I think this is, and another advantage is I think this would allow us to account for certain disagreements in judgments of actual causation. So one straightforward example is there's a lot of discussion about causation by omission, right? So can a doctor cause somebody to die by withholding medicine? Is this really a case of causation? And what's interesting is you get sort of radically different opinions about this, even though people all kind of agree on what the causal model or the causal structure is, and that sort of building in some ideas about defaults would be an interesting way of trying to explain some of these. So this is just to give you a sense of, I think there's still, this is an incredibly fruitful area. There's a lot of great work to do. I hope Judea will join us in thinking about some of these. I'm sure he'll continue to make revolutionary contributions. And just to wrap up with a few kind of reflections. So I often encounter other philosophers who say, I've heard about this computer scientist that everyone's talking about. What's the story with that? So I have a kind of a standard line that I always tell, and you just heard me say this before. And what I say is that Judea is a great philosopher, especially when he's not trying to be. And and I usually get a little chuckle out of that. And I don't mean that he's kind of the philosophical Inspector Clouseau, kind of stumbling onto good ideas without knowing what he's doing. But I actually find him incredibly powerful thinker during the little asides. These might be the parts of the articles and the books that some of you skip over to get to the algorithms or the theorems. But when he takes the time to explain how he's thinking about things or explain the motivation for why he's doing things in a certain way, I find these passages, and a number of people talk about reading Yuda and him leaping off the page. What my sense is just of this incredible richness of these sort of layers of thinking that you're exposed to when you read the work. And when he explains things, there's incredible insight, there's incredible reflection. And as a philosopher of science, one thing that's sort of a familiar phenomenon to philosophers of science is that the most brilliant scientists are often very unreflective about what they're doing and why they're doing what they're doing and how they're doing it. And you try to get them to explain it to you, and what you get is something sort of hopelessly facile or something that kind of clearly won't work or is about as helpful as the old Monty Python skit about learning to play the flute. You blow in one end and move your fingers. But what you get from reading Yuda is the opposite of that, of somebody that's incredibly reflective and aware and conscious of his own thinking and of his own assumptions as he's working through the material. And that's just personally one aspect of the work that I've always valued and really valued. And just to wrap up, I've learned so much from reading your work and from the times we've met in our email exchanges, so thank you.